There's a place beyond the reach of light, beyond planets, moons, and solar winds. A place so quiet it hums with ancient energy. It is here, nearly 24 billion kilometers from Earth, where Voyager 1 floats in a darkness so complete it feels like the edge of time itself. Launched in 1977, this spacecraft was designed to outlast everything we knew about engineering, but no one ever imagined it would survive this long and still be talking. Yet now, in a twist no one saw coming, Voyager 1 isn't just transmitting data, it's revealing secrets. Something has changed. The signals coming from the probe have shifted in a way that defies decades of scientific expectations. Encoded pulses, impossible temperature fluctuations, and strange positional behavior are all converging into a single concerning conclusion. Voyager 1 may have encountered an anomaly or an unknown phenomenon. What exactly is present in the deep void between stars? Why has Voyager 1 experienced unexpected data patterns and begun transmitting new information that has intrigued NASA's scientists? What you're about to explore could deepen our understanding of deep space and possibly our place within it. Voyager 1 began as an ambitious mission to photograph the gas giants, a journey expected to last no more than a decade. Its original route took it past Jupiter and Saturn, capturing never-before-seen details of their moons, storms, and magnetic fields. But as the mission concluded its primary objectives, NASA realized something extraordinary. Voyager was still healthy, still capable, and still moving. And so they allowed it to continue, setting its course toward the unknown. For decades, the spacecraft continued sending data across the vast emptiness. Scientists received updates on the interstellar medium, solar particles, and background radiation. But what's even more incredible is that all of this was done using 70s technology, a probe with less memory than a digital wristwatch, operating purely on radio waves and plutonium decay. Voyager wasn't just surviving, it was thriving. But as time passed, subtle changes began to appear. Instruments flickered to life on their own. Software that hadn't been updated in 40 years began behaving unpredictably. NASA attributed it to cosmic radiation interference or hardware degradation. After all, a probe this old had every reason to act erratically, but the frequency and pattern of these anomalies were too precise, too synchronized to be accidents. In August 2025, the Deep Space Network picked up a transmission unlike anything previously recorded from Voyager 1. Instead of the expected slow, droning stream of scientific readings, engineers were met with bursts of tightly timed pulses. Each burst carried layers of data that, when decoded, showed harmonics, frequencies that suggested resonance. Some researchers hypothesized it could resemble a form of structured data, not one used by humans, but one that could exist in the vacuum of space. Then came the most baffling part. One of the thermal sensors, believed to be long inactive, began emitting temperature data showing cyclical patterns, measurable changes that had no clear source. Voyager 1, drifting in the coldest part of known space, was registering fluctuations, and not randomly. The cycles were approximately every 4.88 hours. Consistent, rhythmic, but unexplained. Even more puzzling, Voyager began to respond to NASA's pings with unexpected timing, transmitting packets of information that appeared misaligned with the incoming request. This behavior sparked curiosity in the engineering teams. How could a machine with no onboard AI, no advanced prediction algorithm, exhibit such behavior? And why was it happening now, after more than 4 decades of operation? As ground teams analyzed these anomalies, Voyager initiated an unexpected adjustment. It began altering its own trajectory. Without instruction, the probe made micro-adjustments using its remaining fuel, slightly shifting its course. NASA's attempts to correct it were acknowledged but not fully executed. It was as if Voyager was experiencing a calibration drift or responding to an external factor. The new trajectory pointed toward a region of space with no known star, nebula, or gravitational anomaly. To the naked eye, it's unremarkable. To infrared and gamma ray scans, it shows minimal activity. But according to Voyager's data, something is present, something emitting a faint pulsed frequency that aligns with the signals Voyager began sending recently. Additionally, its cameras, thought to be powered down, showed signs of activity. Instead of capturing star fields or distant galaxies, they produced a spiral-shaped distortion pattern that resembled a magnetic field map. The pattern appeared dynamic, with numerical ratios tied to hydrogen signatures. Voyager wasn't capturing light. It was recording data patterns. Within weeks of receiving the spiral data, researchers at NASA and partner institutions were deeply engaged. The pattern wasn't just visual. It had structure, complexity, layers of information embedded in electromagnetic waveforms suggested an organized phenomenon. It was a signal, and not just any signal. It contained prime numbers, frequency intervals, and vector maps. Then came a significant observation. Voyager transmitted a coordinate, one that intersected with the galactic plane at a specific distance. When plotted, it formed a triangulation point involving 3 known pulsars and a region between them. It was, in essence, a location. Experts began to analyze. Was Voyager detecting a natural phenomenon? Was it relaying an environmental anomaly? Or was it influenced by an unknown factor? The scientific community was engaged in rigorous debate, but one thing was clear. This wasn't a simple malfunction. This was a complex data set, one built using Voyager's own systems, its own data protocols, and its operational history. And now, it's oriented toward that region. As Voyager 1 continued into the region it had been redirected toward, its instruments began to pick up data that challenged conventional models. The data didn't suggest a black hole or a dying star, nor was it a cloud of dark matter. What it detected was an unusual region, so distinct that even the cosmic microwave background radiation appeared to behave anomalously around it. The team at NASA's Jet Propulsion Laboratory compared the data with archived sky maps from earlier missions and noted an inconsistency. A star documented in optical surveys from 1997 showed no detectable presence. Not dimmed, not collapsed, but absent. No trace of infrared heat, no gravitational influence, no lingering radiation. It raised questions about data accuracy or an unknown phenomenon. Some scientists discuss the possibility of an observational error or an uncharted cosmic event. Soon after, Voyager 1 transmitted a string of anomalous signals that, when analyzed, revealed an unexpected pattern. Not the usual background hiss of deep space, but a coherent pulse. It repeated at precise intervals, resembling a structured signal. What intrigued researchers was the timing of each pulse. When calculated, it suggested a complex origin, possibly tied to an environmental phenomenon. Theories ranged from natural astrophysical processes to instrumental artifacts, but one possibility was considered carefully. Voyager may have encountered an unusual region of space warranting further study. As news of Voyager's findings spread, researchers using advanced telescopes pointed their instruments toward the coordinates. What they found was intriguing. There was no visible object, no structure, no planet, but the space there showed subtle gravitational anomalies, like a lens effect with no clear mass at its center. Even more curious was an observed pattern resembling Voyager 1's data signature, despite the probe being light years away. Was this an instrumental echo, a data artifact, or an environmental effect? The data suggested that the region might exhibit unusual properties, possibly affecting light or data propagation. Could Voyager be approaching a region with unique astrophysical characteristics? Amid ongoing analysis, a group of researchers published a hypothesis. Using advanced simulations, they proposed that Voyager had entered a region of space with distinct physical properties. In this area, matter, energy, and information might follow different patterns. Their models showed a repeating structure within the latest signal, suggesting a natural or instrumental origin. Something had produced a complex data set accessible through Voyager's frequencies. What if Voyager's path had intersected with an uncharted phenomenon, one that revealed new aspects of the cosmos, observable only under specific conditions? What Voyager 1 has uncovered is not just a scientific anomaly, it's something deeper. A cosmic puzzle that challenges our understanding of space and our observational methods. For nearly 5 decades, this small spacecraft has drifted silently through the void, carrying the dreams and questions of humanity. And now, as it reaches the farthest limits of our known universe, it may have encountered a phenomenon that expands our view of the cosmos. Are we on the verge of new scientific insights? Have we detected an anomaly that prompts further exploration? One thing is certain, this isn't the end of the Voyager story. It's only the beginning of a new chapter. One that encourages us to refine our understanding of our place in the cosmos. So, what do you believe Voyager has encountered out there? An instrumental glitch? A natural phenomenon? Or something yet to be understood? Share your thoughts on Voyager's findings in the comments. And if this exploration sparked your curiosity, don't forget to like the video. Subscribe for more scientific discoveries and hit the bell so you never miss what's coming next. Because if Voyager 1 has revealed new questions about the universe, what else might we uncover in the vast unknown?